So let's get into our agenda. Today's webinar is going to focus on data analytics. This has been something that the private sector, especially in the SISE working group, has been talking about for some time, is how do we better manage interdependencies between sectors based on our 15 years of doing this. A lot of folks, plus or minus 10%, everyone knows what's going on within their specific sector, whether it's transportation or energy or what have you. The trick is what's going on in the other sectors that people may not be aware of that could actually take them offline in a day or two or three. And so today we wanted to put this call together. Many of you opted in, if you will, to be part of the DHS NIPP Security Resilience Challenge over the last several years, and we're gonna just give you a quick update on that. We are recording today's session, so if you have to drop off, we'll have it available online afterwards, and we won't get anything too sensitive today. Mike or Tony, are either of you on the call yet? Okay, not yet. Okay, so we'll skip opening remarks. I'll just get into a brief on where we are with the DHS Security and Resilience Challenge Program. In 2016, DHS announced they were going to do some investments into rapid development of solutions to help improve critical infrastructure. The All Hazards Consortium was one of 10 recipients for that. We put together very quickly a project that built upon the previous 10 years of federal investment, state investment, and private sector investment, and continued to develop out a framework that was designed to share information quicker, faster, more securely, more reliably, that would be run by the private sector but include government as equal partners and work on use cases together that they could define who sees what when. So that project was renewed in 2017 and 2018, and this project has evolved over the last couple of years into a community of several thousand stakeholders nationwide. They are working on use cases as a way of focusing attention, so they build a use case, set up committees, and work towards solutions. I didn't ask for formal comments, Kent, but Kent Kildow from Verizon is the chair of the SISE working group. Kent, I thought maybe if you have just a second, maybe you want to share kind of your thoughts. You've been with this since ground up, right? So it's come a long way since we started. Maybe you want to provide some comments just for the group perspective.
Sure. I guess just thinking about this strategically, the ability to bring together data sets and help create a operational picture that people can use to make decisions and help get back to normal faster is of critical importance during a disaster. And this framework and this process of critical and sensitive information sharing really provides the opportunity for business to business, and in some cases public to private information sharing like we've never seen before. And so the potential here is really dramatic in the way that we may be able to move the ball in directions that we've never been able to do before. Oftentimes there's some loose agreement that yes, the information sharing would be helpful, and then you get into questions about how the information is going to be controlled and how long will access be available and who has access to the information, and it starts to break down pretty quickly. My perspective is that the SISE has helped answer a lot of those questions and put us in a position to really advance the work forward quickly at this point. So I think that provides a quick overview of my perspective on things and might help illustrate some of the importance of the work that's going on. Tom, is that?
Yeah.
I think that's kind of what you were looking for.
Yeah. No, Kent, that'd be great. And I meant to have you introduce yourself and your background for those that may not know you. I'm sorry, I should have done that up front.
Yeah. Not a problem. Just to help, I guess, expand on that piece. I continuity and emergency management at Verizon. I have responsibility for our global programs for both, planning and response to major emergencies.
Great, thank you, Kent. I wanted to let folks know that by focusing on use cases, we've been able to drive out specific products, information products. Over 80 have been produced over the last several years, since really 2013, but it's really gone on steroids through our partnerships with Edison Electric Institute in the electric sector, the food sector, the fuel sector, DHS, and it really drives out solutions that can be used. Just as an example, as we get ready for the 2019 hurricane season prep, there's roughly 7 new items we're going to test here for this season. Some are almost ready to go, others are ready to go, but they range from transportation, accelerating transportation data sharing, to developing some new decision-making dashboards that are built on absolutely the most reliable data out there today. We have a committee that is comprised of 11 utilities and 6 states that have federated an agreement on a standard to rank data to see if it's a 1, meaning ready to go, or it's a 4, meaning needs some more work. So they're looking at a number of these use cases as we go forward that have been in the oven for a while. These will be launched here this hurricane season. We're also looking at a couple of new ones. Kent is certainly part of one. One is, after Hurricane Michael, this whole concept of reducing fiber cuts during power restoration efforts. Chris Eisenbray is on from Edison Electric Institute, and Ken is on from Verizon, and I thought maybe, Chris, invite you to share some of your perspective, and then we can jump into the rest of our event here. But I think this is a big issue, developing use case. Chris, any thoughts before we go to the next one?
Sure, Tom. Just briefly, not sure if everyone's aware, but there were some instances during the Hurricane Michael restoration efforts where telecommunication fibers or telecommunication services were inadvertently cut due to crews' lack of awareness of what the fibers were for. Their lines and our lines typically are on the same right of way, on the same poles, those types of things. Some fiber was also disrupted or cut due to what we call push crews, and these are crews mostly hired and working for state DOTs or local or city, municipality governments, pushing debris, moving debris to open up roads, and inadvertently through that process, fiber gets cut. Our infrastructure, in some cases, is cut as well. So we've been engaging some of the PSF2, which is the emergency support function for telecommunications, the FCC, their Bureau for Public Safety, and also some of the providers. And how do we, as an industry, the electric industry, coordinate better with our friends in the cross-sector telecommunications industry? The solution is not a top-down solution from the FCC or the Department of Energy. It really needs to be solved at the ground, at state, local, and county EOCs, and just having better information sharing, better situational awareness on infrastructure would help to do that as our two industries work to better coordinate. And I think having a system like the one that's being discussed today is a good step in the right direction in providing that situational awareness and what those cause and effects might be.
Great. Thank you, Chris. We're also looking at another one before we jump ahead on fuel distribution. Apparently there are fuel distribution delays that could be reduced significantly based on what we're hearing from the fuel sector, and we'll be looking at a new one for that as well. So today, the reason we're here today is one of the things we've been looking at is this whole predictive analytics, right? Not 100% accurate, but what could we do to improve decision making for not just what's going on at present, but what could be happening in 4 hours, 6 hours, 12 hours, and so forth. So in our partnership with DHS, we've looked at a number of different technologies, and DHS referred us to this project they were working on with Idaho National Labs. We have looked at this as a potential tool and gateway to help alleviate part of this. But many sectors are dependent on other sectors, right? Disasters cause disruptions all the time. So how do we get ahead of this? So some of the key questions we've been working with the private sector on is who's watching and managing these interdependencies. It's too big for one company or one sector. It really is a role for federal government in the appropriate way, not to manage it, but to kind of watch for these things. It's a difficult thing for any one sector to do. How can private sector leverage government's analytic capabilities, but at the same time protect their information, right? How can this data be used for blue sky and black sky day applications? One for planning, response, recovery. How do we do that? How do we affect future investments in critical infrastructure based on analytics? And lastly, how does the private sector mask and protect that information so that it is not available to any non-operational use or anyone outside of their control? These are the issues we've been working on through this use case. So as over the past, I guess about the last year, this partnership has been developing with DHS. We certainly know the folks at Idaho National Labs, many long-standing relationships with that organization, DHS, and the consortium in its states. And so today we wanted to have a discussion around this technology and explore ways we can actually use or test this in the future. It might not be a year, it might be a little farther out than that, but I think it has great potential as far as getting real information data into that, protecting it, and yet producing information that is valuable to the private sector. So it's a visual tool, which I think is really great. The idea is to put the information in there, secure the access to this, restrict access to the appropriate people as defined by the use cases. At the end of the day, the big idea is on the left, we have private sector providing the following items, okay, to be determined. DHS on the right providing the following capabilities, and most importantly, the outputs of this are joint planning in a safe, secure, media-free, regulatory-free environment through the SISE, which is a legal framework that protects all that as people opt in, and it allows that to happen. How do we create and operationalize solutions? And more importantly, how do we have a single place we can all do this, whether regardless of sector, that this can be beneficial? So I'm really happy to have you folks see this and talk about it here. So I'm going to introduce Shane Cherry from INL National Labs. Shane, I'll turn it over to you here, and we can jump into the presentation, and then we'll have discussion afterwards. So it's all yours, Shane. You got it.
Great. Thanks, Tom. I appreciate the opportunity to share some of the work that we're doing with DHS, and also look forward to potential opportunities working with the All Hazards Consortium and your stakeholders. So kind of give a little bit of history of Cascade. Where a long time ago, like a lot of other entities, Idaho National Labs started to look at critical infrastructure interdependencies and modeling and simulating those interdependencies so that they could help decision makers in crisis action or in preparedness planning, some of those different things. And so we started off doing very high fidelity infrastructure models. Had great models doing good things, and the question always kept coming back is like, well, where are you getting the data? And this is great that you've built up this very high fidelity model for this specific area, but the hurricane landfall predictions just shifted. You have the information for that new area to do this, and having those high fidelity models is always very difficult to scale. So it made it very difficult very expensive to maintain, very expensive and difficult to get the level of detail that you needed in the information over large geographic areas. So we started looking at it at a little bit of a different approach where we were doing more data-driven or data discovery type of things, and really looking more at the functional relationships and functional dependencies among the critical infrastructure. And by understanding those functional relationships and dependencies, we feel that it allowed us to much more quickly identify kind of the facilities and the relationships overall. So we started to develop a capability internal to INL called the All Hazards Analysis Framework, or AHA. We did that with internal research and development funds. Since that point, DHS, NRMC, has sponsored development of a better and more intuitive front end to the AHA framework, and that's what you're going to see here with Cascade. And what Cascade is really a web-based application for infrastructure analysts to discover and understand the dependencies among nodes and infrastructure networks. Allows you to visualize existing dependency information, allows you to identify and enter your own dependency and infrastructure information as it's identified or discovered. And as Tom mentioned, I think that's going to be a great partnership or a great opportunity with state and locals and private sector for them to be able to add the information and knowledge that they have in a secure environment, protected environment, that really allows much more rapid decision support services. So with that, I'm gonna kind of turn it over. We're gonna kind of co-pilot this, myself and Kenny Larson, who's one of the developers of Cascade here at INL. And just want to make sure before we get started, can everybody see the Cascade login screen?
Yep, we're good on this. Yes.
Yeah.
Okay. All right, good. Well, we'll go ahead and get started with login here. Okay, so what you're going to see at the beginning here is basically a geospatial framework that allows us. A lot of what you're going to see is looks very similar to a lot of other geospatial capabilities that you see, and that's on purpose. We don't want to incorporate tools or capabilities that aren't intuitive or aren't useful for folks. So we're really trying to make something that's very easy for stakeholders to be able to use the system, get information out of the system, and doing so in a way that they don't have to be GIS experts or programming gurus. So what you're seeing right now is just kind of a nationwide view of the U.S., obviously. And I'm going to turn it over to Kenny here. He's going to walk through some of the things that we do to add data. And before we get in there, one thing that I want to mention with the data behind this, in addition to developing the capability itself, the interface, the programming, all of that, for DHS, we're also working with DHS to develop a nationwide kind of baseline lifeline infrastructure data dependency data set. So a lot of the information, and that's ongoing, so a lot of the information you're going to see in here is related to that interdependency build out that we're doing. It's conducted all open source, and is with multiple different information sources as well. And so we're developing capabilities to merge that data, maybe starting with like HSIP, what used to be HSIP Freedom or Gold or whatever, combining that, the values of that with what you may get out of EPA data sets, combining that with what you may get out of FCC data sets, National Pipeline Mapping Service, basically mining a lot of all this information to develop what we're calling these baseline dependency data sources. So with that, I'll turn it over to Kenny.
Yeah, so what we've done here is we've given the analyst an easy way to query and put data onto the map. And so you can look at this map filter over here, and you can look at the different facility types. And these are the different sectors that you can filter by. And as you can see, we've built out quite a few sectors or facility types that you can query by. So we'll just put in airport here and show you how we can put some data onto the map.
This is going back and querying the database. You know, this isn't just a regular GIS database. It's actually loading all of the dependency information and everything and the nodes that we have associated with these. And as we start to go through this demonstration a little more, you'll start to see that we're looking at 10 degrees of dependency information. So you can see that there's a lot of information there. So sometimes it's not. That data doesn't appear just with the click of the mouse. But we are using some advanced technology on the back end with Neo4j graph-style databases
where that graph-style database backend becomes very important as well, because it allows much more flexibility than a standard relational database.
Hey, Shane. Shane, this is Tom. Just to interject, if I may. This is for the group, but I'll dialogue with Kent. So, Kent, this would be the kind of the master data that would be just so much data it's overwhelming, right? And this is where we would use use cases to pull from all these different pieces, so we have a simpler decision tool. You're going to see pretty robust stuff here, but I wanted to make sure people understand kind of the concept of how we get all this mashed up into one, bring it down into one use case. We might have multiple boards, if you will, for multiple use cases, but I think you'll see when they get into this, they're pulling from data from all kinds of, I guess, public, federal, all kinds of information. The SISE data would be separate, but I just wanted to make sure we frame that up, because there's a lot of information here. I think it's great, Shane. I didn't see this before, so that's it. I just wanted to put a point of reference in there for how we work by use case and funnel the data through that. Go ahead.
Yeah, no, that is a great point. There's definitely a lot of data in here, and so what we've done is we've given the analyst or the user the ability to go in and drill down into the different sectors. And so if you wanted to search for water treatment plants and substations, and you could include this in the facility types query, then we could filter that down even further by searching in Texas, and then we could search in Harris County, and we could apply the filter. And then what that would do is it would show us all of the water treatment plants and the substations in that specific region. And so this query tool gives you the ability to quickly throw that onto the map. Was there anything else? Yeah, so this is the map view, and then we also have another view that you can use to analyze this data, and it's just up here in this facility list, and it's just another tabular grid format that you can use to then go search for the data. So there are multiple ways to look at this data that you queried. So then there's another scenario where you don't necessarily know the counties, but you know the region on the map that you want to search. And so we can search using a lasso tool. And so if we put in water treatment plant and a substation, and we built out this lasso tool that will allow you to select the region that you want, and you can click apply, and it will bring up all of the facilities that are of type substation and water treatment plant. So those are some of the query tools that we have developed and built out.
Yeah, those are the standard kind of GIS capabilities. A lot of it, again, is the data behind this. We didn't want to add anything complex, being able to go in and identify facilities. But what this does is allow it, and what you'll see, too, in the map is a blue dot with water there, and so with a water symbol, water drop. And what this is when you go in and you look at facilities, you can add them to a watch list. So if you're interested or you want to focus on a specific facility for your analysis, you can go in and add it to our focus list. I call it a watch list. It's a focus list. So you can do that. And we did that before with the water treatment plant. Specifically, we saw that when our initial query, we weren't identifying the other water treatment plants or substations in the area that may be associated with it. So we went back to use the lasso tool to get more representative information in that area. So from here is where we really start to get into, the power of some of the data behind it. And this is really looking at some of the interdependencies associated with these facilities.
Yeah, and so we have this example right here, which is Thomas S. McKee Water Treatment Plant. And what you can do, since we've already added this to our focus list, is you can come into this focus list and you can actually look at the upstream and downstream dependencies for this particular facility. And what you do is you just drag up on these bars here on the right, and it will put as many dependencies on the map as you specify here in the number of degrees. So it allows you to scale that up, and then you can come down here and you can look at the upstream and downstream dependencies for that specific facility. So there's another view we've built out, and what this allows you to do is it allows you to see it in more of a graph view, and as you hover over the specific facility, you can see the name of that facility. And these are just different ways that the analyst can ingest and work with the data.
So Shane, let me interject for a minute. So Chris, Kent, this goes back to you pick a use case, and so this is kind of where it hit us. So in that window on your graph view on the right, Andrew, right there. So the items in blue on the bottom are private sector. The ones above are government. Let's say I'm just picking it as an example. But this is a great example of where you have cross-sector, whether it's transportation, whether it's railroad, air, or it's infrastructure. These are the pieces that I think folks are missing. And as we've been talking through just one of the use cases with the fiber cuts, we've learned more about what's going on. The real issue there is on the government end of it, not so much on the private end of that, but not everybody knows that. So I think the way you display this can really drive the dialogue. We can come back to that later, but I didn't know you had that graph view, but I think this will give the audience an idea to say, hey, look, this is how, if they intersect government and business, other times it may be sector and sector. There's no government involved, and vice versa. So go ahead, Shane. This is good. I'm glad you've got the graph view.
Yeah, so we have the graph view, and so this graph view is showing the dependencies on that specific facility, and then we also have the option to look at the generic profile, which is an ontology of the types of facilities and the hierarchy of the types of facilities that exist for this specific facility.
Yeah, so this is really looking at, so when you look at a water treatment plant, this is where we got into kind of the functional approach for data collection is we first wanted to understand a typical water treatment plant, and there's different implementations of those and nuances we know. But for the most part, we can start to understand what are the input commodities that a water treatment plant requires. I mean, obviously there's electricity, obviously there's raw water coming in, but there may be disinfectant, there may be some other things. And when we felt if we can start to build out what we call these generic profiles for all these infrastructure asset types, one, it allows the analysts, again, they don't, for certain scenarios, they don't have to be subject matter expertise or have subject matter experts within these specific systems or facilities. We can kind of give them initially an idea of here are the types of things that you need to look for when you're considering a facility such as this. And then that also allows us to very rapidly collect information to start populating for a specific facility like what you see in the map. And again, this will come up a little bit more when we start to show how you can add your own facilities and identify and add your own dependencies within an area.
Exactly. So what we'll do is we'll just take these dependencies off of the map and return to here. And so as an analyst, it's possible that you might want to place a facility onto the map. So what you could do is you could change to our satellite view, zoom down into the area that you are looking for. And we have the option down here to input data by placing this node onto the map. And what this does is when you place that node on the map, it will automatically populate the latitude and longitude for this new facility that you are adding. And so let's just put in test water facility. And then you could come down here and select the type. And once again, we have all of our types. And for this example, let's just do water treatment plant. And then we can click and save that. And it will take you into this property section. Currently, this facility doesn't have any properties. And
one of the things I'll say about the properties is as we get going further on the development of this, that's really where you start to add in information such as gallons
dependencies for this specific facility. And so we're given a list of commodity types that this facility can accept or output. And so for this case, we will select electricity, meaning that this facility accepts electricity from an upstream facility. And then what this does is it will give us a list of facilities in the nearby area that provide electricity. And so we can select one of these and add that dependency. And then what we can do is we'll just quickly look at what we just did by taking a look at this dependency that we just created. Switch to. So you can see that we created a dependency with this nearby substation.
So the idea behind this is that, yeah, I mean, we can develop some baseline interdependency data layers, but you know, the local knowledge of an area is always going to be much greater than what we can do from, in this case, 1,000 miles away. So we want to really develop a capability that has the basic information in there for interdependency information that we can verify and validate right now, but also leave it open for the local stakeholders to be able to add the information and update it based on their local knowledge and expertise.
So we will just take off this dependency right now, and we will return. We had talked about the facility types and the hierarchy, and we've given the analyst or the user the ability to go and actually look at those facility types. And on the left side of the screen, you can see that here are the top level facility types that a user can select. And what you can do in this view is you can look at the different types of upstream and downstream dependencies that those different types provide or accept. And so we could come in here and we could look for water treatment plant, and it would show up here. Or we could go and look for nuclear generation plant, and it would show us the upstream and downstream dependencies for that type.
Hey, Tom, this is Sherry Black. I just wanted to interject here for a moment. One of the things we're trying to do by creating these facility profiles is understand that, you know, data, when it comes to these analytic exercises, data's always been, you know, the limiting factor and the long pole in the tent. So recognizing that these are engineered systems, it's possible to characterize them, understand in general inputs and outputs, and get the 80% solution, maybe not the 100% solution that you would get if you actually had the time and money to invest in data collection about every critical infrastructure facility. But to get that 80% solution by doing these upfront profiles and characterizations that frankly are close enough until you get to the point where you really need to drill down further.
Yeah, thank you, Sherry. And I see it as a dual prong. One is the back end where you're building kind of this framework. But you know, every storm, we are reminded of this. And Tom Farmer, are you still on with us?
Yes, sir, I'm here.
I will not forget. I don't know what storm it was, Tom, but there was a rail bridge washed out last year. I think it was last year. I mean, it was a big issue, and the rail sector fixed it. But this was one of the things. It just kind of hit me with, okay, well, what is delivered by rail? Well, pretty much everything is delivered. It could be fuel or whatever. Anyway, I just think when we hit these use cases, Tom, I don't know, maybe you could talk to that, but you know, based on that route of rail, if you remember the incident, I don't remember what storm it was, but I remember it was a lot of water and the bridge was washed out. But the rail sector is kind of a backbone for a lot of things. Tom, maybe you can speak to what was the rail line and what was the major commodities that move up and down. Was it fuel? Is it coal? That's the kind of thing that every time we have a storm, we have these stories that come up. Maybe for those that aren't aware of it, maybe Tom, you can remind them of that. But that use case, I think, can drive these types of things. So, Tom, any comments?
Well, my recollection is it was the routing into the Wilmington, North Carolina area as part of the effects of Hurricane Florence last season.
Yes.
And we were precluded from getting train operations. The principal service provider in that area was CSX. There was also a number of short line carriers in North and South Carolina that were affected by the flooding disruptions. In terms of the commodity, the Port of Wilmington was served by that line. Additionally, there was a military installation there that used an industrial line that was blocked for a period of time due to the flooding. In terms of how we would support an initiative like this, we can very quickly, and in fact in advance of storms, have available information on the types of commodities that generally flow, which would, I think, justify the use case that you're referring to. What is this? Is the significance of a line? Does its blockage cause any particular disruptions to other industries because commodities can't get into the area? We did have a challenge in the storm that hit predominantly northwest Florida last year, where a couple of the key retailers involved in providing materials for the response and recovery effort for restoring homes and other structures, certainly they relying upon the delivery of commodities by rail from the outside. It was very important to get, particularly CSX, back in operation so that we could at least have a means to get the materials close. A couple of the short line carriers that would usually finish the ship were out, so could not, due to flooding, operate. But we were able to use CSX to get materials very close, and then trucks were brought on, and CSX was a good intermodal operation to complete the delivery. But I think to your point for the broader group, the objective is understanding what the interconnections are, what interdependencies might be implicated because you lose service for a time, and then what's the estimate in terms of the response. And as you've indicated, our teams are very good. Sometimes they're just hampered by the nature of events, and the Hurricane Florence in the Carolinas was particularly problematic because you had that other element of flooding, and all the water then would have to go through areas that seemed okay for a bit, but were going to be reflooded as the inland waters began to flow down towards the ocean. And that obviously implicates one of the key priorities we have in the private sector, and that's ensuring we have very good GIS data available on that sort of information. And that became one of the priorities that we addressed during the storm season last year. And this year is a priority we've worked with the federal government on trying to get advance approval for access to that sort of data. And that kind of information could support your efforts here as well. The more we know on how water in particular is likely to flow, the better decisions can be made on where to commit resources to not having to duplicate efforts. Don't want to clear out an effort that in a couple of days' time is going to be reflooded because of the natural effects of severe inland heavy rains and the natural flow of water that good GIS data can give us good modeling on. So hopefully I covered the areas that you were looking for.
No, thank you, Tom. Sherry, Tom just gave an example. I think every disaster we have is going to breed the use case, and that will define the people, the roles, and the data needed. What is missing from that is the interdependency discussion. Because when you look at a disaster, what's the impacts? Well, the impacts vary based on the sector. You can take the same storm, Florence, and look at different sectors that impacted differently. And I think my point is, as we build use case committees around this, those are the groups that could help populate some of the interdependencies we're talking about here. But it might be after the event. But then now you're building every event. You're building, a database of interdependencies. Instead of going to the private sector now, hey, give us your nationwide interdependencies. Maybe we focus on an event one at a time, and over a year or two, we build 50 or 80 of them. That was my point, right? Because you're right; these are all local, Shane, and they got to be done as part of an AAR sometimes, right? As an after action. But Tom's example in the rail sector it's in every sector that way. So maybe some of the electric folks or the comm folks want to talk about an example of how that works. But my point was, if we had committees formed around these things, I think that could help populate the tool. Anyone have comments about that?
Well, Tom, that's an excellent example because the use case that caused us to look at during Hurricane Florence was the movement of water treatment chemicals by rail and the areas that would be impacted by the inability to move out of Wilmington or into Wilmington.
But Tom, this is Shane again, and I'll ask you. I mean, you hit it right on the head. Where there may be some after actions or some other things that populate this data. And one of the kind of underlying values of this tool is that it's a learning tool and a knowledge management tool as well. So as you lay out those use cases or scenarios in one area, and start to define some of those interdependencies that maybe people that aren't obvious or that people aren't necessarily thinking about, you capture them for that local area or that use case, but then it's ready to be used in a different area as well. So it really allows that knowledge sharing, if you will, between different regions, different stakeholders, and whatnot. So when you see on the screen like these upstream dependencies and downstream dependencies, I mean, you can add some more information once you start to identify in more fidelity, what you're looking at. So it's not static. It's something that is intended that folks can learn from, and that the knowledge base grows.
Well, thank you, Shane. And that was kind of my point was, Kent, you and I were talking, there's probably going to be a long road for, hey, Verizon, give us all your, nationwide interdependency data. That's probably not going to happen, right? But if we were to zero in on a specific issue, we probably could have the right people at the table to begin to look at the interdependencies between state, local, comms, and electric on this specific use case. Am I zeroing in on it?
I think that's a fair assessment, Tom, that, this gives us a framework where we can really start to expand the conversations and get into a more operational approach to the conversations versus a theoretical approach to them. So it's going to put us in a position to move things forward from my perspective.
Great. Thank you. Go ahead, Shane.
Trying to say we may have.
So we just have, I guess, one other view that we can show, and it's the ability to actually drill down into a specific facility. And what this does is it just gives you another way. It gives you a lot of the same functionality that you have on the map. It just blows it up a little bit and allows you to focus in on one specific facility. And you can do similar things like looking at the dependencies, and you can edit the facility and see its upstream and downstream dependencies. So, with that,
I think that's kind of the end of what we had to show, Tom. Again, it's not a complex system. It's not intended to be. It's intended to be relatively simple and easy to use. So that's where we're at.
And so, just a couple questions. If I'm the private sector and I have sensitive information, I don't want this out there. Based on what I saw today, I could come up with a mock-up of information and dependencies versus giving you my data. I could actually have my 4 or 5 sites, as a mock-up. I could put them within 5 miles of where they are. It doesn't really matter that much, I guess, in the interdependency piece. I'm looking for a way to protect private sector information, so they're not giving out the exact coordinates or some of the too sensitive information, which is just not gettable. Does that make sense? How would you? Is that something we could do?
Yeah, obviously you can do that. I think there's pros and cons to that. Obviously, the pro is protecting the specific locations of the facilities and stuff if they are sensitive. The con to that is a specific event coming in, like flooding or high winds or something else that kind of has a specific geographic area. You may lose, or you would lose, some of the accuracy of your scenario by doing that. But the other thing, I think this is where we get into potentially looking at some of the future requirements of this partnership is through the SISE working group and the framework that you already have set up to protect the information. We can develop things to where people with a role, that only that private sector entity has the ability to see their information. We've done that within other applications as well. So I think that there's definitely various ways to address some of the data sensitivity concerns.
Yeah. Well, and I think there's probably a number of them we haven't even thought about yet, but I thought at least we have a capability here, and if there's a way to leverage this so that we get smarter each storm, instead of what I've seen happen over my career is we tend to repeat. Not because we're stupid, it's just people leave and the data goes with them, right? We tend to repeat these things, and maybe this is a way we could actually get ahead of that curve over time. Let me pause for just a minute. I'm going to take the screen back for a second, Shane. For those that are not aware, the SISE working group has a methodology model that I think has proven extremely effective. And it starts at the top with the problems, and at the bottom are the data sets, and then they work up through the use case of worth. It seems to me that we could introduce analytics right above kind of the sector use cases for because that's what's missing here is how do we inform Tom Farmer and his members about things going on in other sectors that could impact him 48 hours from now, right? How do we inform electric sector that these things are going on over here that could impact them in 24 hours? That was kind of the big idea, and I think let me pause for a minute. I'm just going to go around the horn and get some feedback from some of the folks in the private sector that are with us. So, Patty Early, are you on from Florida Power Light, Patty?
I am, but I apologize. I just had somebody in my office, so I missed part of the conversation.
Okay, that's fine. We'll circle back. I know Jeff Dorco. I know Jeff, you're on. Are you still with us? Okay, Chris Eisenbray. Any perspectives again now that you've seen the tool? Must be Friday. Ken, I know you're on. This is just my life. This is just my life.
And Friday, getting towards the second half of the afternoon.
No, that's okay. That's okay.
I've said it a couple of times. The ability to understand the operational realities out there and bring together disparate data sets on the fly and pick and choose those really creates the opportunity for decision makers to understand the challenges that they're facing and put solutions in place. And this does absolutely have real world application that can advance the model that we've been working on. You bring a good point up too, Tom, and the fact that it's not going to be a short-term one and done and have everything in place, but continuing to build on the capabilities and the trust and the access to data. This does help us, move that conversation forward as well. So I absolutely see the potential here.
And Tom Farmer, I thought about you when I saw this because as former chair of the Cross-Sector Coordinating Council, I mean, it just seemed to me this would be something that councils could work on night and day, right? If we had the right people there. Do you agree? I mean, to me, this was all about cross-sector learning and sharing, and I know they do a lot of that.
Yes, Tom Farmer here. We often talk about creating foundations for effective cooperative efforts, coordination, information sharing, and then we look to improve them forward. I think you've done far more than set a foundation. We've got a process here that can demonstrate its value and based on experience be improved upon by those working in the different sectors who are looking to provide information in effective ways for that broad cross-sector awareness. I think the real value, particularly for the chair of the Critical Infrastructure Cross-Sector Council, when he or she is called upon to try to highlight what are the significant areas of concern, where are the issues, opportunities, particularly for government intervention, perhaps to remove logjams, to add to the efficiencies and what's taking place as part of a response effort. This sort of tool would be exceptionally useful for that purpose. If you think about the challenge that the cross-sector chair has in trying to put together all of the different streams of information that are now flowing largely by email from representatives of different sectors.
Yeah.
From the full group or to the chair. If there were a system like this, readily available, where that sort of data, essentially say one action by the organization, the representatives of different sectors putting information into this sort of a system, and the chair of the council and providing a good snapshot for partners of government as part of those recurrent phone calls and other means of communication. This would be a tremendous resource to draw upon. And it would highlight, often on those calls, Tom, as you well know, participating in them, a lot of questions, a lot of issues come up over and over again. And I think this sort of resource gives an effective means of demonstrating, well, why do those questions keep coming up over and over again? What action isn't being taken? And what can we do cooperatively to make a difference? So that the next call, we can say those issues were addressed, or at least they're on the way to doing so. So thanks very much for the effort, for the opportunity to address.
Now, Tom, you just said what I was trying to say, is those calls really highlight the need for something. And if we could just build a library, these going forward, I thought it would be great. Stacey Neal, you're on the phone with us from Virginia, Stacey?
Yes, I am.
I'd love to get your perspective from the kind of the ground truth. I mean, as you run critical infrastructure there, maybe give us your thoughts on how we leverage this from the state perspective.
So, for the past 3.5 years, I have been the Critical Infrastructure Program Manager for the Commonwealth of Virginia. And one of the very first things that was brought to my attention when I took the job was that we didn't have an inventory of our critical infrastructure across the state. Not a good comprehensive inventory. State agencies were keeping infrastructure that was important to them in silos, if you will. So the first thing I tried to focus on was getting that inventory, but then I started applying why did I really need that information? I started asking myself that question. And it boils down to, we don't necessarily need to know where all the critical infrastructure are physically exactly. But what I need to know is, what is the critical function that they serve, and who do they impact if something happens? And so for the last 3.5 years, I conducted a port risk assessment in the Port of Hampton Roads to identify critical infrastructure, assess their criticality, and then look at upstream and downstream dependencies. And ultimately, that's what we really wanted to know, so that we can do some future planning. If we know this water plant or this water utility is out of service for whatever reason, then we know it's going to affect X population. But inside that X population, what other critical infrastructure exists that are providing critical functions that we really need to start planning for impact to? And so that's really what the program in Virginia and in the National Capital Region as a whole. I sit on a working group with counterparts from Maryland and D.C., and that's really where we've been driving our efforts for the last 3.5 years. The Idaho National Labs system came to my attention a couple of months ago, and so this is my second demo of the system, and it's the first system that I have seen that truly captures in a meaningful way that information and presents it so that we can actually use it to make decisions. So I really, really think that we're headed in the right direction with this system, and I know it's being piloted in one state at least, and I hope that here in Virginia we're going to be able to leverage the system as well.
Okay, thank you, Stacey. So I wanted to throw this out, since we've been working this for a couple of months. One of the things that I wanted to propose would be, first, to move this forward as next step, is to let's pick a use case or form a use case around this. We have a number to pick from. We create a committee, 5 or 6 people to work the issue. we put data in that, produce a sampled product, and we circle back the wagons here for a, kind of a tabletop discussion around it. We gather recommendations for enhancement, and we operationalize in the next storm for testing. To me, I think putting this information could be really, really valuable, not just as a critical part of an after-action report, which I think would draw out, Sherry, from my perspective. I think the AARs can really draw a lot to this. But I think, Stacy, getting the state's perspective on this is really, really important, because from my perspective, the states have the best connection to all the dots in their state that there is. That's not going to be a federal person. It's a state person who's been in there for a long time. That could bring a lot of information to bear on this capability. And then we just build these products as we go forward, while on the back end, DHS is continuing to populate the data. Anybody got any thoughts or another approach that they'd like to explore with this?
Hey, Tom, Dave Hillenbrand.
Hi, Dave. Go ahead.
I just want to give you an example of something that happened to us a few years back. We had a storm, and it was in November, and I don't remember what storm it was. And we received a call from, I believe it was the state or Public Utility Commission, and said, this was a big storm, we realized, but on Tuesday, all the voting poll areas, where you would go to vote, all those must have electricity by Tuesday morning, because people need to vote. And as an example, there might be, you might go to a fire station, and that's where you go to vote. Well, we know on our system that customer is a fire station. We didn't know that it was a voting polling place to vote. So something like this, and each storm could be different, but in a case where we could have had something like this and went into that and tried to find out where all the polling stations were, the voting stations, it would have made it a lot easier. So we were panicking for a couple days, one, trying to gather data of where all those were, so it was calls to local government and trying to find out, what places were people able to vote. That's just one example where you don't know what data set you need until the time of the storm, or you understand what I'm saying?
Yes.
So I don't know what kind of data is available, or is there, requests that could be made to say, hey, can this, and this, all the schools, all the voting places, all the whatever.
Yeah.
I don't know. I'm just throwing stuff out there
Yep.
that would make, it seems like quickly you could gather a lot of data just from that system. I don't know if I'm talking or making
Tom, Tom, let me jump in for a second. I think you're absolutely making sense, and that's one of the items that Tom referenced earlier, is that use case approach to data acquisition and curation to make sure that we have those data sets available to all of us, and that they can be mixed and matched based upon the use case you're trying to solve for in the moment. The curation piece is important, though, to make sure that we're getting the right data sets brought in, and that the right due diligence is being given the data sets before we get to a black sky day, so that we can make sure that the accuracy and the updates to those data sets and all of those kind of things are where we need them, or that we understand that they're maybe a little older, and therefore you have to take that into consideration when you're going through your decision-making process. Tom, I hope you don't mind me jumping in on that one.
No, I'm just taking notes.
Hey, Tom, this is Dave Animal. Can I speak for just a second?
Sure, go ahead, Dave.
I appreciate your invite.
Yeah, just introduce yourselves so everybody knows who's talking. So, go ahead.
Dave Vanderblom at Dominion Energy. Been working with All Hazards and SISE for a couple of years. Been doing emergency management for a few as well. The cool part about what we've been doing, Tom and Kent and this group, is understanding every time we look, we find out there's more and more data. The bad part we find out is there's more and more data. And our goal has always been to provide information so that you can make decisions in 30 seconds, right? To be able to look at it, to be able to understand it, and act upon it. And as I hear all these different use cases come up, and each one of them, I could spend individually with everyone. The polling places, I can tell you what we've done for that, because if you're in a swing state, you know what that is. The data is king. What I like about this format is it starts to let people know everybody, when an emergency occurs, when it hits them, they're number one. And this allows all the different cross-sectors to understand we're all in this together. How do you prioritize it to get the community back to normal? How do you get there? In our industry, in the electric industry, in our transmission system, you're looking at these things. You're talking about N-1, N-2 contingencies. Our transmission grids are running those algorithms every 60 seconds, twice every 60 seconds. So if anything fails, how do you identify it so it doesn't take out something else and you get a cascading event? That's done automatically. Where you can do that on an electric system, you're not going to be able to do that with 15, 20, 30, 40 different cross-sectors. You'd go nuts. So we got to remember, and I don't know who was talking in first, that the 10,000-foot level is great. It starts the conversation. But if we ever try to automate it and stop the conversation, that's the key is where's the automation to start the right conversation so you can make the right decision. So I like it. A lot of cool stuff here. I'm looking forward to where it goes next.
Well, thank you, Dave. Any other comments? I know we're running over. I just, Shane, Sherry, team, I want to thank you guys for doing this. This will not be the last date. I think this is just a start. I think as the SISE brought sectors together from a legal framework, this could be a capability that brings sectors together from operational planning, where they actually are working together, planning, getting analytics that help them work together, decide better. I just saw a great potential here, and the federal government's paying for it, which makes it a little easier sometimes, because this is a hard thing to do. But anyway, I just if anybody has any other comments about next steps, we can talk about it within the SISE work group, Kent. But it seems to me if we could pick a use case form on it, maybe the election would be good. I mean, that could involve comms, power, transportation, the voting folks. I mean, that's rail. That's got it all, and it's a hot issue right now. At least up until the next election, that's a new one. And maybe we can look at something on the cyber side of this. Is there some cyber small, right of boom kind of thing we could look at? But we'll take it up in the SISE work group. Greg McShane, you got any thoughts or comments before we adjourn from DHS perspective?
Yeah, I saw the earlier version of Cascade, and this has come along quite nicely. And my mind starts racing on how do we implement this and coordinate this on our watch operations between NRMC, day-to-day operations, our briefing teams, and all the things that we have with the SISE. I mean, your mind starts racing and how we can do this better with the private sector. But, the better we can close the data gaps between government and private sector works definitely to our advantage. And, I think the stage is really set for that. And we're excited to do this and really move the ball forward for the next year. So and it doesn't stop then. So great work, and look forward to it. Okay,
very good. Shane, let me say thanks again to INL and your team, folks. I want to thank you all for jumping on a call Friday afternoon. At the end of the day, the slide on the screen is what it's really about, is better cross-sector planning, decision support, and overall reducing risk to our infrastructure, to our citizens, all of us. So anyway, thanks all. Have a great weekend. If you're traveling, please be safe. I'll send an email out with a link to the recording for your review and share if you'd like, okay? Thank you all, and have a great afternoon.